Do we agree with that? Yeah.
Can't you just say that that y prime is 1?
How do you know it's 1?
Because it's
No, so the derivative, again, we're doing, and that's why, like, the prime notation is going to be messing you guys up. We're taking the derivative in terms of x. So this whole problem, we're doing d dx. So d dx of negative x is negative 1. Leave this alone. D dx of y is what? It's dy dx. It's the derivative. What we're doing here is everything, the derivative is d dx. So derivative in terms of x. So this is d dx of negative x. This one, and you should write it like that, you know, like if you're having trouble with it, instead of the primes. This is d dx of negative x, which is negative 1. Derivative of this in terms of x. D dx of y, this is dy dx. You're saying this isn't 1 because you're taking derivative of y in terms of x. This is dy dx, or y prime.
then you say it's negative.
And that's what you would do. If you want your second derivative equation in terms of just x's and y's so that you can just plug in your point, your x and y values, from here, I know what y prime is. It's negative x over y. So that you can just plug that in. Cool. Now I want to know at the point, how fast is that derivative changing? What's the rate of change of the rate of change at the point 3, negative 4, without a calculator? Without a calculator, what is the second derivative without a big plastic thing? Let me rephrase. Without a giant plastic thing in your hand, with a pencil and your brain. I want to know what the second derivative is at 3, negative 4. Without the calculator. Okay. Well, if we plug in 4 plus 3 times negative 3 over negative 4 all over 16. Oh my gosh, there's fractions times the fractions. So this is, this is positive, so this is 9/4. And then I want to get this with the common denominator, so that would be 16/4. This is negative divided by negative is a positive, and then multiply your numerators, multiply your denominators. So it's like 3 over 1, which is positive 9/4, and then I change the 4 so I can add those two together. So the 4 is the same as 16/4. Now you can add your numerators together and you get what? 20 what? 25/4 divided by 16 is the same as 25/4. 25/4 divided by 16 is the same as 25/4 times 1 over 16. Which equals what? 25 over 64. For you chemistry people, who's in AP Chem? Is this going to work 16 times 4? That's your oxygen molecule, right? Does that come up all the time?
Yeah.
I knew all my multiples of 16 because of Chem. 25 over 64. How are we feeling with that, you guys? So that's the value of the second derivative for this circle at the point 3, negative 4. Questions? the derivative of this relation is. Does that make sense, Amina? Why the derivative of y is y prime? In terms of x, we're taking all our derivatives in terms of x. We will switch that later. Well, it's not 1. Because y prime was negative x over y for any x. You know what I'm saying? Now, if you took the derivative in terms of y, if you d dy, this would be negative dx dy. Then that would be 1. You know what I'm saying? If you took the derivative in terms of y, which we haven't done. You know what I'm saying? Because you can switch the variable when you're taking the derivative in terms of. And it's just the same rules. So if you did like, if you did x prime, if you want to know what x prime is, if you want to know what dx dy is, you do the same rules, only flipped. So then whenever you do an x prime, it's not 1, that is dx dy. And then whenever you do a y, that would be 1. And we're going to switch all the variables, because it doesn't matter, you know what I'm saying? Yeah? So like for you, I would use the notation then more, instead of my lazy primes. Because the notation really understands what you're taking derivative of. Does that make sense? I'm just lazy. And it's cleaner. It's cleaner with the new primes, but it doesn't make sense. You know what I'm saying? It won't make sense. So I would take what you're taking the derivative of in terms of x. And then you'd see, oh, this is 1, but this is dy dx. That's y prime. Or just leave it as dy dx and solve for dy dx. Do you know what I'm saying? You guys, when you do, what is this over here?
18 y prime.
You took the derivative of x and y at the same time. You broke every product rule possible. This would be 18x if you want to say it like this. 18x times y, the function 18x, times the function y. You got to product rule it. Okay? You see it? So, what is this side? This side I think everyone probably got. What's this side? 3x squared times dx dx, which is 1, plus
3y squared
times dy dx. Exactly. And leave it like that. Like, if you truly want to understand the notation, I would keep on writing as that, the times the dy dx. You have to do my lazy primes. You know what I'm saying, Wayman? Just because I'm lazy doesn't mean you have to be. Okay, so I'm going to set this up as a product rule. Derivative of the first plus the first times the derivative of the second. What's the derivative of 18x in terms of x? 18. What's the derivative of y in terms of x? Dy dx.